Welcome to yet another class. I'm Dr. B. I'm your chemistry teacher online, and today we are going to be doing something about wave number and frequency. Remember that in our previous classes where we have to discuss how we can be able to arrive at a mathematical formula that defines radiant energy. I promise us that we're going to do a few calculations in that regard so that we can be able to understand how we can calculate in a very simple terms some certain mathematical questions that has to do with the UV-Vis Spectroscopy or the IR. Now, here we have a question. It says calculate the wave number and frequency associated with radiation of a wavelength of 120 nm. As simple as it is. A lot of us will be wondering, how do we go about this? If you can remember our previous classes that we had discussed determination of the radiant energy in the UV visual spectroscopy, this will not be an issue. But never mind, I'm going to take us through how we can do this, referring to what we had done earlier. Now, do not forget to share, do not forget to like, do not forget also to do what? To comment. Now, when you share these classes, please endeavor to tell your friends and colleagues to do what? To hit the subscription button and subscribe with the bell showing a good. And then the Facebook page is Dr. B Chemistry Classes, and you just go in there, share, and ask them to do what? To follow, to like, and to do a subscribe. That will keep this particular aspect of our online classes going and well appreciated. Alright, now we said calculate the wave number and frequency associated with radiation of wavelength of 120. Now there is something you must note. Now if we must answer this question, we should know that we are given in this question, we are given 120 nm. And what is this? The lambda here is what? Your wavelength. We are given wavelength. So the first question says wave number before you have frequency. How do we determine wave number? Wave number is the same thing as the radiant energy. Yes. The wave number equation is the same. And when you recall what the radiant energy equation was, in case you cannot recall, I will assist you. Now, the radiant energy equation is given as 1 over lambda. Remember, that was the equation we arrived at if you had watched my previous class on this. And if this is true, then it means we have lambda given already. And how do we do that? We are expected to substitute 120 nm into this equation. But do you know that this particular equation ends in per centimeter? Because the wave number is in per centimeter. So wave number is 1 over lambda in centimeter. And if it is in centimeter, it means it is not going to be the same. How do we then convert how do we then convert from nanometer to per centimeter? That becomes our problem. Because we need to do what? To convert the nanometer into what? The centimeter. But it's not a problem. Always remember that, always note that 1 nanometer is equals to what? 1 times 10 raised to power minus 7 centimeter. Always take note of this. When you always remember that 1 nanometer is equivalent to 1 times 10 raised to power minus 7 nanometer, then you are fine. Or you also can say that that 1 nanometer, okay, that 1 nanometer is equivalent to 1 all over 10,000, 10 million. That is it. As simple as that. 1 nanometer conversion is equivalent to 1 times 10 raised to the power minus 7 centimeter, or 1 divided by 10 million. If we agree that this is the conversion, That means that if 1 nanometer is 1 times 10 to the power 7 minus 7, then 120 nanometer is 120 times 10 to the power minus 7. So that means that we will simply see our wave number is equals to 1 all over what? 120 times 10 raised to the power minus 7. That means that is all we have. 120 times 10 to the minus 7. Or what you have is going to be 1.2 times 10 raised to the power what? Minus 5. Yes. Either you have it as 1 all over 120 times 10 raised to the minus 7 as this. Or if you are going to use this, then you are going to divide 120 by 10 million. And that will give you 1.2 times 10 raised to the power minus 5. Whichever one you want to use, fine. So when you arrive here, it simply means that our wave number can also be divided. That means we can say 1 over 120 multiplied by 10 raised to the power 7 over 1. How do we get into that? Remember that this is more like a denominator. So when we move 10 raised to the power minus 7 across the quotient sign, that is division sign, this sign that accompany it will change. It will change from minus to plus. And that is why we're having what? 10 raised to the power 7. 1 divided by 120. Pick your calculator immediately and do that. Let's see. 1 divided by 120 should give you a value that is 0.0083. Yes. Times 10 raised to the power 7. This 10 raised to the power 7 is this one. And this divided by this is this. But do you know that this value can be made in an exponential form? And if it can be in an exponential form, that means that this value will be what? Will be 8.3 times 10 raised to the power what? Minus 4 times 10 raised to the power what? 7. That's what you have. Of course. Because 0, 1, 2, 3, 4. That gives you minus 4. 8.3. 1, 2, 3, 4. Give you minus 4 because the zeros are beginning from your left going to your right. So you have minus 4. Okay. This equation is the same thing as 8.3 times 10 raised to the power minus 4 plus 7. That is your indices. First law of indices. That's your first law of indices. Alright, so this will give us minus 4 plus 7 will give us what? Plus 3. So your answer therefore for the wave number is equals to 8.3 times 10 raised to the power 3. And it is in centimeter per centimeter. Now this is your answer for that. That is simply saying 8300 per centimeter. That's what it simply means. So from this question, your wave number is simply 8.3 times 10 raised to the power 3 per centimeter. That is the wave number. If you know what wave number means, then you will know what this value represents in a UV visible spectroscopy experiment. But this is for the wave number. What happens to the frequency? Now, if we are going to look at what happens to the frequency, we must take note of the fact that we have discussed already what radiant energy is, and the definition, mathematical representation of frequency is in that equation. Of course, it's in that equation. Alright, so in that case, we are going to look at that. I'm going to look at what it is. So now let us clean this and look at that. Now, frequency, which is the second one, frequency, which is V, is equal to C over lambda. Do not forget that this equation was discussed earlier, and this equation was where we got that the speed of light C is equals to what? V times lambda. The conversion arrived here. So if the frequency is speed of light over lambda, what did we say is the value for the speed of light, which is a constant? Do you remember? In case you do not remember, we said it's 3 times 10 raised to power 8 per second. So that means that we will now have 3 times 10 raised to power 8 per second all over lambda. Our lambda value is what? Our lambda value is simply this value we have here when converted to what? Per cm. So it is what? 120 times 10 raised to power what? Minus 7. Yeah. So if we have the value of our lambda, which was converted here, look at it here, then it means we have the constant and the given. How do we go about this? Just remove this 10 raised to power 7 and take it up. If you bring it up, this sign, which is minus, will change to what? A plus. That's what we had here. So we're going to do that now. We're going to do that now. So we'll now have, so it means that the value of our frequency will now be 3 all over 120 times 10 raised to power what? 8 times 10 raised to power what? 7. That's what it means, because we have decided to pull this and bring it up here. So the sign will change. The sign convention will change. Now, if that is true, this is the same thing like saying 3 over 120 10 raised to power 8 plus 7. And this will give us 3 divided by 120. Pick your calculator now and do that. Let's see. If you say 3 divided by 120, what do you think you will have? You're going to have 0.025. That's what you're going to have. And then times what? 10 raised to power what? 10 raised to power 15. Because 8 plus 7 is 15. Okay, that's what you have. Now, do you know that this value that you have here can also be changed into a decimal? That means you can also have 2.5 times 10 raised to power what? 1, 2, 3 minus 3 times 10 raised to power what? 15. Therefore, our frequency will be equals to 2.5 times 10 raised to power what? If you say minus 3 plus 15, it will give you what? Plus 12. And that will give you 12. And this will be automatically the value of your what? Now this is your frequency, of course, so it's going to be in what? Per second. So this is the value of your frequency. So for this question, you never needed any other thing just apart from what? The wavelength. And once you convert the wavelength from nanometer to centimeter, you are good to go. You need to calculate the wave number, which is equivalent to your radiant energy or transmitted energy, and then you calculate also your what? Your frequency. Equations that are all obtained from the derivation of the radiant energy that we did in our next class. I want to believe that you enjoyed this class we have just had here. You will be able from now to determine wave number and frequency from a simple equation or even a complex one given to you as far as spectroscopic analysis is concerned. Until next time, I remain Dr. B, your favorite online teacher. Please do not forget to subscribe. Do not forget to share. More importantly, please share these classes and tell your friends and colleagues to also do or hit the bell button for subscription. Go to Facebook and do the same thing. Tell them to follow while we share these classes and to like and to comment. Until next time, it is a bye for now.